Hello. Well, we're going to look at a solution of graphs. Let me just go to this image that we need to look at. Well, we have a formula which is y equals 4 e to the power of negative half x sine 20 pi over 7x. For us to change the value from big positive, small positive, a 0, a small negative, and a big negative. Leave all the other constants. Now we're going to look at this variable 4. Okay. So I've put, what I need to do is change the 4 and leave everything else. So let's go over to a graph and we put this into the graph. We've got 4 and there's the graph that we've got. All we have to do is choose a big positive. So I'm going to change that 4. So let's just go back to that 4, backspace. I'm going to put in a big positive. Let's go 20. Now watch what happens to the graph now. Actually, rather than just changing that, let's leave that graph. Let's copy that. Let's put that whole graph as a red graph and let's change that to 20. And let's see what the graphs look like. Oh, let's select both of them. All right, there's the original. Now here's the 20. What happens? Let me just change that x-axis. We've got an x minimum at the moment, a y minimum at -7. Let's change that to be, say, -21 and change the y maximum to be 21. And that's the 4. And there's the 20. What can you see that's happening? All right, let's change it again. Let's make that now a small positive. Let's make that just 2. All right, that's the original. That's the 20. And there's the 2. What can you see that's happening? All right, let's change this now to a 0. Change that value to a 0. And let's join that. That's the original. That's the second one with the 20 value. That's the third one with the 2 value. And there's the 0 value. Look, it's basically making everything 0. All right, now let's go to a small negative. Let's put a negative in there, -2. Let's sketch this. We're getting a lot of graphs on this function. That's the original. That's the 20. That's the 2. There's the 0. And here's the -2. What can you see? -2. And look at -2 and +2, the black and the green. The negative, you should be able to see what this is doing. Let's make it, let's go this equation here. And let's go back to being the same size. But what we're doing is changing it from positive to a negative. All right. What happened? That's the original for 4. There's the 20 value. There's the 2 value. There's the 0. There's the -2. And here's the -4. No, it's the same color as +4. That's fine. We're getting a nice pattern coming along here. And finally, let's make this our large negative value. We'll copy that, paste that down here, put in a -20. All right. 4, 0, -2, -4, and -20. Okay. And that's just changing the value of the 4. So what we go back to the original question, leave all the other constants the same. We didn't change the -1/2, and we didn't change the 20 pi over 7. Describe in a sentence how each value affects the vibrations. Well, here's where you make your observation and make your decision. Each value, the positives increase the amplitudes, the small positives decreased the amplitudes, the zero flatlined it so that it eliminated any height so that the function value was zero the whole way through. The negative reflected it in the x-axis, and the large negative was a large amplitude reflected in the x-axis. So it's the same as the positive. All it did was the negative values reflected whatever the positive values were, and instead of being a positive, they all became negative. And that would be your description. You'd have to state that in a sentence. All right, so I hope this has helped this particular activity. I've only looked at the 4. You can play around with the other functions, the other values, and see what happens. Until next time, stay happy.